Hello everyone, I hope you guys are doing well. So today we're going to be connecting everything that we've learned, square roots, squaring, Pythagorean theorem, 45, 45, 90 triangle, and also linear equations, y equals mx plus b. And yeah, it's going to be a really cool task here and activity. So I want you guys to pause the video and I want you guys to try this problem out. I'm assuming that you guys did. So let's go over number one first. First is saying draw a square with the side length of 10 units with the diagonal line going from the bottom left corner to the top right corner on a graph with the bottom left corner or the bottom left vertex of the square at 0, 0. So if you guys drew it correctly, it should look something like that. So as you guys can see, let's see if it meets all the requirements that we talked about here. So with the side length of 10 units, so as you can see, this is side length of 10 units. Okay, so side length of 10 units, 10 units. With the diagonal line going from the bottom left corner to the top right corner of the box or of the square. And then on a graph with the bottom left corner, okay, of the square at 0, 0. So that's 0, 0, bottom left corner is there. Okay, so that's what you guys should have drawn. And automatically you see, okay, this seems familiar. This, as you can see, is a line. It's a linear equation. And so that's what we're going to do. What we're going to do is number 2, write the linear equation for this line. So I want you guys to now pause the video and I want you guys to try this problem out. Okay, I'm assuming that you did here. So we're going to write the linear equation for this line. So if you guys remember, the first thing that we always have to do is we have to write the formula for the linear equation of the line. So if you guys remember, the formula looks something like this. It looks like y equals mx plus b. Okay, so that is how it should look like, y equals mx plus b. All right, so I'm assuming that you guys wrote this down, and if you haven't written this down, please write this down. And so once again, you know, this, just to review a little quickly, this m represents a slope, and this b represents the y-intercept. Okay, and make sure you write this down. And remember, slope controls the steepness of the graph, steepness of the line, actually, steepness of the line. And then the y-intercept controls the height of the line. Okay, so we're going to draw a linear equation for this line here. So as you can see, the y-intercept is 0, so b is going to be 0. So b is going to be 0. And the slope, as you can see, is rise 10, run 10. If you guys remember, slope was m is equal to rise over run, right? And then right now, my rise is 10. And my run is 10 as well. Run is 10, which is equal to 1. Now, it doesn't necessarily have to be 10 over 10. It could be 5 and 5. I could have drawn my rise like this. That's horrible. I could draw my rise like that. That's run 5, rise 5, and that's run 5, right? So that would be the same thing. 5 over 5 is equal to 1, right? Or, you know, if I do choose another number, okay, I could do this one, right? If you take a look here, I'm rising 1 and running 1. So that's 1 over 1. And 1 over 1 is equal to 1, right? So it doesn't really matter which points you choose. The slope is always going to be the same. I can choose any 2 points on this line. I could choose this point and that point, and that'll still give me a slope of 1. So 3 over 3, right? 3 over 3 is going to be 1. So it doesn't matter which 2 points I choose. No matter what, I'm going to get the slope of 1, okay? All right, so as you can see, my slope was 1, right? And so if I rewrite this, my m, so it's y equals, once again, my equation is y equals mx plus b, right? So y is equal to, what's my m? My m is 10 over 10, which is 1. 1x plus b, which is equal to 0. So my equation is y equals x, okay? Now, if you want to leave it like this, that's still correct. But if you simplify it, the equation is going to be y is equal to x. And the reason why is because the y-intercept is 0, and x plus 0 is just x. So if I actually draw this line, it's going to look something like that, okay? So I'm just going to show you just a graph of it, okay? All right. Whoops. I'm just going to show you the graph of it, all right? Got the whole thing. All right, so that's my equation for the line, right? Y equals 1x plus 0. So 0 is my y-intercept here. 0 is my y-intercept. Rise 5, run 5, that's a slope of 1. Or rise 1, run 1, rise 1, run 1, rise 1, 1, run, so on and so forth. And that is my slope. So now what we're going to do is we're going to get this square that we drew, and we're going to put it on top of this linear equation line, okay? So if you take a look, put it on top. And as you can see, they correspond to each other perfectly. Okay, gonna draw like that. Yes, it's a little bit off, but it's fine. Okay. Okay. So as you can see, this diagonal of the square corresponds perfectly to y equals x. Right? So let's go back to what my question was. Write the linear equation for this line. So my equation for this line was y is equal to 1x plus 0. Y equals 1x plus 0, which is what we got here. Y equals 1x plus 0. So I'm going to bring this over here. Okay, bring this over here. So we have the answer for number 2. Okay? Bring all this stuff to the right. Okay. So that is the number 2. Write the linear equation for this line. Okay. So we're writing the linear equation for this line. Okay. We're writing the linear equation for this line. Okay. Or the diagonal. Okay. All right, and then now we're gonna set the constraints of the linear equation so it doesn't exceed the length of the diagonal of the square. So if you guys can see right now, the length, the equation, right, y equals x is exceeding, right? It's longer than the diagonal set by the square, right? The diagonal set by the square goes from x is equal to 10, or x is equal to 0, greater than x is equal to 0, but less than x is equal to 10, right? Greater than 0, but less than 10, the x values are, right? So we have to set this constraint, which is number 3, right? Set the constraint for the linear equation so it doesn't exceed the length of the diagonal of the square. So how do we go ahead and do that? Okay, so we're gonna do it like that. So if you guys take a look and put it into Desmos, we're going to set the constraint from 0 to 10, right? 0 to 10, and x is going to be between those values. And so this is what we did for the art project. And if I bring this over here, this 10, right, like that, it's going to fit perfectly. Voila, you see that? So this square and this line perfectly fits. And now the line y equals mx plus b, y equals 1x plus 0, which was, this line right here, this green line, is no longer than my diagonal here. See, it was longer here, right? It was longer here, but now it fits perfectly here. Okay. All right. So I'm gonna bring it up like that, and there we go. Okay. So that's the answer to my third question. I'm gonna bring that down here, so we have it working for us. So now we're gonna answer the next question. Let's take a look at what the next question is. All right, now the question is, what is the length of this line? Okay, so now we're going to, I want you guys to pause the video and try it. All right, so let's see, and let's take a look. How do we find the length of this line? So if you guys take a look, we're going to, this is a right triangle. You guys see that? This is a right triangle. In fact, it's not just any right triangle. It's actually a 45, 45, 90 triangle. Because remember, this is a square. And this right here is 90 degrees. And if we cut that in half, it's going to be 45. That's going to be 45 degrees. And that's going to be 45 degrees. And this is going to be 90 degrees. So as you can see, we're working the 45, 45, 90 degree triangle, okay? So, so we learned about the 45, 45, 90 degree triangle, and there we can use either the Pythagorean theorem or we can use a conjecture. I'm gonna show you both ways on how to find the length, okay? So let's bring it all the way down here, next to our problem, okay? All right, so let's take a look. So the lengths are 10, right? The lengths are 10. So I'm just gonna put into the equation 10 squared plus 10 squared, and 100 plus 100 is equal to 200, and square root 200, and then factor out to 2, simplify the 100, and it becomes 10 square root of 2. So the length of this line actually, right, is actually 10 square root of 2. So when we set the constraint, of this linear equation by from 0 to greater than 0 but less than 10, which is inequality, is what we've been talking about, the length actually becomes 10 square root of 2. So the answer for this length is 10 square root of 2. But you don't necessarily have to just use 10 square root of 2. You don't have to use a Pythagorean theorem. You could use the conjecture that we've learned. So as you can see, the lengths are 10, right? If the lengths are 10, if this was 10 and that was 10, if x is equal to 10, right, x is equal to 10, then that would be 10. So my answer is going to be 10 square root of 2. And we don't have to necessarily do the Pythagorean theorem because we can just use the conjecture of the hypotenuse, right? Which we have right here. So that's how we do that part, okay? So the answer is right here. The length of the leg is 10 square root of 2. Not length of the leg, but length of this line, y equals mx plus b line, or the diagonal, is 10 square root of 2. And I hope now you kind of get to see how that's all connected. We're talking about the linear equation, and that linear equation is actually related to the diagonal of the square, which is also the hypotenuse of a triangle, which is also the length of this hypotenuse, which we can find using the 45, 45, 90 degree triangle conjecture or the Pythagorean theorem. Right, so all of this, the linear equation, all that stuff is really, really beautifully connected. So now let's take a look at the next one. All right, so what is the length of this line? We found that. What is the area of this square? Okay, so we were talking about area a little bit, and I do want to just show you guys here. As you can see, if we count all the squares here, right? So let's count all the squares. So I'm gonna get rid of this here. I'm gonna count the squares. So that's that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So that's 10. And how many do I have of here? So I have, how many 10s do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 10s. which means that if I were to count every single one of these squares, and if you want to pause the video, it's gonna be 100 little squares. 100 little squares. Okay, so there's gonna be 100 little squares here, which means, by the way, 10 times 10, right? Because there are 10 of these, 10 in a row. And how many rows do I have? I have 10 rows. Okay, so it's gonna be 10 times 10, which is equal to 10 squared, right? Which we've learned that this square is literally referring to a square with the length of 10, right? A square with the length of 10. So that is how we find the area of the square, right? And you know, how can we find the side length of the square given the area of the square? Okay, so how can we, you know, find the side length of the square? So how do we find it? So remember, the area is 100. Okay, how do I find it? I just square root it. Okay, which is the same thing as square rooting a square, right? 100 is the same thing as 10 squared, right? And then square rooting 100 is just 10, right? Therefore, square root of 10 squared is also 10, right? So how do we get the length of the area of a square with the length of 10? Take the square root, right? And then it gives you the length of the square. And remember, we also learned about how do we undo the square. We take the square root of it, because square rooting it will give you the length of the square. And we can also find the area of this triangle if we wanted to, right? We can also find the area of this triangle, right? So if we draw a line like this, it's going to be kind of messy. Actually, let me see if I could draw a line. If I draw a line like that, okay. Then, and I just want to find the area of the triangle, or one of these triangles, right? If I wanted to just find one of these triangles, if I just wanted to find the area of one of these triangles, it's just half of this, right? It's a half of 100. As you can see, this is a half of this entire square. So the area of the triangle is just 50, right? So you see, which is the same thing as 1/2 base times height, right? I don't know if you guys know that about the equation of the triangle, but that's where that comes from. That's where that comes from. You get the square, right? Base times height, which is 100. 10 times 10, which is 100, right? 10 times 10 is 100. Half of that, which is the half here, right? So this is where the equation for the triangle comes from, because you find the half of the square. But that was just a bonus. So anyways, that is the end of the performance task. And the reason why I did this is because I want you guys to see how everything that we've learned all throughout the semester, they're all connected. There's not a single thing that isn't connected to one another. If we go back, this square is connected to this linear equation, right? This square is connected to the linear equation because the diagonal can be represented by a linear equation. But we can also set the constraint, right? Using the art project, we learned about constraints. We can take the constraint and then set the diagonal of the line be not exceeding the length of the diagonal. You see that? And we can use that to find now the length of the hypotenuse or the diagonal, or the length of this line, which is y equals mx plus b, using the hypotenuse, right? This equation or this equation, or this conjecture, right? So you see, all of this stuff is just beautifully connected, and I hope that while you do this problem, you can see just the beauty of how everything works. Okay, so that's it, and I hope you guys enjoyed this video, and I'll see you guys in the next one. Okay, bye bye.